problems on electric field and charge. Electric charge and field. We shall take up the problems on this. First problem is 2 point charges minus 15 microcoulomb and plus 20 microcoulomb are located in air 0.9 meter apart. Find the force between them. If a medium of relative permittivity 8 is introduced between them, what will be the new force? See, it's a very simple problem. He says, here are the two charges. One is minus 15 microcoulomb. Here is a minus 15 microcoulomb is one charge placed at A. And other is the placed at B, which is plus 20 microcoulomb. So plus and minus under Gabriel, they are unlike charges, they get attracted, understanding? They are separated by a distance of 0.9 meters in air. Okay. Now he says, find the force between them. When they are in air, what is the force? Then what he says, he introduces a medium of relative permittivity 8 in between them. Given the problem, you must write the data. Data Q1 is equal to minus 15 microcoulomb minus 15 into 10 to the power minus 6 coulomb. Q2 is equal to plus 20 microcoulomb, that is 20 into 10 to the power minus 6 coulomb. And D is the distance between them, it is 0.9 meter. And he has given the absolute, that's the permittivity of the medium, which is equal to 8. You know that when the charges are placed in air, so when charges are placed in air, the force is given by F is equal to 1 by 4 pi epsilon naught Q1 Q2 by D square. Since it is placed in air, you would call it as a FA. And your problem is, it is 9 into 10 to the power of 9. It is minus 15 into 10 to the power of minus 6. And another is 20 into 10 to the power of minus 6 whole divided by 0.9. 0.9 if you want, you can write as 9 by 10. So that since the square is there, it would be easy to calculate. Okay, 9 by 10 whole square. Now you simplify all these things. It's equal to 9, the minus sign of 15 into 20 into minus 6 is minus 12, and here is a plus 9, and therefore you are left with minus 3 in the numerator, whole divided by, this is a 9 square, which you can write as 9 into 9, and this is 1 by 100 that comes to numerator. Okay, 1 of the 9 get cancelled. Okay, now what you do is, it is 3 3s are, it is 3 5s are. Okay, now again you can simplify this one. This is 20 into 5 is equal to 100, and therefore your force in air is equal to, it is equal to 100 divided by 3 into 10 to the power of minus 1. Remember that. Okay, I hope, look at the calculation, it is minus 6 and it is equal to plus 9 and it is minus 3. You are getting 100 here, it is minus 1. 20 into 5 is equal to 100 by 3 and it is minus 1. And finally, you will get it is to be equal to 10 by 3. 10 by 3 means it is 3.33 Newton. This is the force in air. Okay. Then, what's the other part he has asked? If you place a relative permittivity 8, ಇಲ್ಲಿ ನಡುವೆ ತಗೊಂಡೋಗಿ ಒಂದು 8 ಯಾವುದೋ ಒಂದು ಪೇಪರ್ ಆದ್ರೆ 4 ಇರುತ್ತೆ. ಪೇಪರ್ ಮೇಲೆ ಇಟ್ಟರೆ ದಟ್ ರಿಲೇಟಿವ್ ಪರ್ಮಿಟಿವಿಟಿ ಇಸ್ ಈಕ್ವಲ್ ಟು 4. ಇಲ್ಲಿ ಯಾವುದೋ ಬೇರೆ ಮೀಡಿಯಂನಲ್ಲಿ ಇಟ್ಟಿದ್ದಾರೆ. ಮೈಕ್ ಆಗಿದ್ರೆ 6 ಇರುತ್ತೆ. ಅವಾಗ ಏನಾಗುತ್ತೆ, ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಟು ದ ಫೋರ್ಸ್? ಅದಕ್ಕೆ ನೀವು ಬರೀಬೇಕು, when charges are placed in a medium of relative permittivity 8, then the force is given by, so that is equal to F is given by 1 by 4 pi epsilon naught into epsilon r Q1 Q2 divided by d square. Since it is placed in the medium, you call it as a Fm. Okay, and look, you separate out this. When you are placing it in air, you know that for air epsilon r is equal to 1. For air epsilon r is equal to 1. That's why we get this formula. For other medium, you have to introduce this epsilon r. Now if you look at this, you will come to know that your Fm is equal to the whole thing which I have rounded off is the force in air divided by epsilon r. Force in air is equal to 3.33 Newton whole divided by this epsilon r is equal to 8. Now you divide this, it's equal to 0. You know that 8 4 is equal to 32 and then it is equal to 1.5. So therefore your Fm is equal to so many newtons. Remember this. What is the conclusion? When we have placed it in the air, force is more. When it is placed in the medium, the force decreases. That's the conclusion. Therefore, when charges are placed in medium, force between them decreases. ನೀವು ಯಾವಾಗಲೂ ಕೂಡ ಈ ತರ ಈ ಪ್ರಾಬ್ಲಮ್ ನ ಮಾಡಿದಾಗ ಹೀಗೆ ಬರೆಯೋದು ಕಲ್ತಿರ್ಬೇಕು ಲಾಸ್ಟಿಗೆ ಒಂದು ಲೈನ್ ಅನ್ನ. ಓಕೆ, ದಿಸ್ ಇಸ್ ದ ಫಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್. ಓಕೆ, now we come to the second problem. The problem number 2. Study the problem carefully. Problem number 2. Force on an electric charge placed in a vacuum at a point where electric intensity is 1 microvolt per meter is equal to the weight of 10 milligram. Calculate the charge. Look, here is a charge. It's an isolated charge. Here is the point P. And what he says, force on an electric charge placed in a vacuum at a point where the electric intensity is 1 microvolt per meter. You'll hear the electric intensity is E, which is 1 microvolt per meter. And that force experience is equal to the weight. And there it experiences a force. So there it experiences a force equal to its weight. Calculate the charge. That is, calculate the charge means it is the test charge you have to calculate. Value of the test charge. So what he has given? He has given the electric field at that point is 1 microvolt per meter, 10 to the power minus 6 volt per meter. And force is equal to, look at that, force is equal to weight of 10 milligram. Force is equal to 10 milligram weight. So what is that? See, he has given the mass of 10 milligram. You are 10 into 10 to the power of minus 3 kg. This is the mass, okay? And into, it's equal to 9.8 because your force is a m into g. So if you want still more clarification, look, your m is equal to 10 mg. That means 10 into 10 to the power minus 3 kg. Okay, and g value is equal to 9.8 meter per second square. Remember that. Always your force is equal to, remember that force is always given by force. F is equal to m into g. M he has given, g he has given. M is equal to 10 milligram. Okay, and therefore that also you can write it here instead of writing it 10 mg. You can write it like this. So this is equal to m into g. Then what is the value of m? 10 into 10 to the power minus 3. What is the value of g? 9.8. Okay? Now, what is the formula that we are going to use? Use the definition of the electric field. It is the force experienced by the test charge. And therefore your Q is equal to F by E. What is the value of F? F is equal to 10 into 10 to the power of minus 3 into 9.8. whole divided by your E is equal to 10 to the power of minus 6. Remember this. Here it is 10 into, if you bring it to the numerator, it is 10 to the power of plus 6. Okay? Now this is 9.8, 10 to the power of minus 2, 10 to the power of plus 6. That comes out to be 9.8 into 10 to the power of 4 Coulomb. Okay. So practically this is a very higher charge, but you remember that your Q is equal to 9.8 into 10 to the power of 4 is a Coulomb. This is the charge he wanted. So he wanted to calculate the charge, the value of the test charge is equal to so much. Okay? So remember this. Maybe the concept is very, very important. It is. Okay? Next. Problem number 3 carefully. Force of attraction between the two charges plus 3 nanocoulomb and minus 2 nanocoulomb separated by a distance 0.2 meter in a certain medium is found to be 4 into 10 to the power minus 7 Newton. Find the relative permittivity of the medium. Look, what he has given is, he has given the two charges. One of the charge is equal to Q1, whose value is equal to plus 3 nanocoulomb. And there is another charge, let me call it as a Q2, which is minus 2 nanocoulomb. These two are separated by a distance of 0.2 meter, and he has given that there is a force of attraction because they are unlike charges. Now his question is, what is the value of relative permittivity? Always you write the data first. Your Q1 is equal to 3 nanocoulomb, which is 3 into 10 to the power of minus 9 coulomb. Q2 is equal to minus 2 nanocoulomb, which is minus 2 into 10 to the power of minus 9 coulomb. And he has given that there is a force of attraction. And the force of attraction is given to be 4 into 10 to the power of minus 7 meter. And he has given the distance between them. And now your problem is, distance between them is 0.2, and you want to find the value of relative permittivity. That's the problem. So ಇದು ಡೈರೆಕ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಇದೆ ಅಂತ ಕಾಂಪ್ಲಿಕೇಟೆಡ್ ಪ್ರಾಬ್ಲಮ್ ಇದೆ, ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ. ಇದು ಕುಲೂಮ್ಸ್ ಇನ್ವರ್ಸ್ ಸ್ಕ್ವೇರ್ ಲಾ ಇಂದ ಬರೀಬೇಕು ನೀವು. ಯು ಶುಡ್ ಸೇ ಫ್ರಮ್ ಇನ್ವರ್ಸ್ ಸ್ಕ್ವೇರ್ ಲಾ, ಕುಲೂಮ್ ಇನ್ವರ್ಸ್ ಸ್ಕ್ವೇರ್ ಲಾ ಏನಂತ ಬರೀತೀರಾ? ಫೋರ್ಸ್ ಬಿಟ್ವೀನ್ ದ ಟೂ ಚಾರ್ಜಸ್ ಈಸ್ ಗಿವನ್ ಬೈ 1/4 pi epsilon naught ಅಂತ. ಯಾವಾಗ ಏರ್ ಅಲ್ಲಿ ಇಟ್ಟಿದ್ರೆ, ಅವನು ಬೇರೆ ಮೀಡಿಯಂ ನಲ್ಲಿ ಇಟ್ಟಿದ್ದೀನಿ ಅಂತ ಹೇಳಿರೋದ್ರಿಂದ ಇಟ್ ಈಸ್ ರಿಲೇಟಿವ್ ಪರ್ಮಿಟಿವಿಟಿ ಇಂಟು Q1 Q2 divided by d square. He has given everything except that value of epsilon r. Now again ಮಾಡಿ, you bring that epsilon r here and you take the force there, and instead of this you write 9 into 10 to the power of 9 divided by f into Q1 is equal to 3 into 10 to the power of minus 9, and it is minus 2 into 10 to the power of minus 9, and d square. Your d is equal to 0.2, which you can write it as 2/10 square if you want. Now therefore, your value of force he has given. Therefore, your 9 into 10 to the power of 9 into, look here, 10 to the power of plus 9, 10 to the power of minus 9 is here. 9 into 3 into 2 in the numerator. You take the minus sign here. Divided by your value of f is equal to 4 into 10 to the power of minus 7 multiplied by this value is equal to 4 by 100. That 100 comes to numerator. So now you know that it is 2 ones are 2 twos are. You simplify that, and therefore your value would be, so therefore, so here in the denominator I have one more 10 to the power of minus 9, and this is 10 to the power of minus 7, and it will get cancelled with this one. Now therefore I am left with the relative permittivity is equal to, all these things have cancelled. Now in the numerator I have got 9 into 3, 27, it is 4 into 8, and therefore it is equal to 27 divided by 8. Don't worry about the minus sign. Minus sign indicates that just it is an attraction. For relative permittivity there is no meaning for negative value. Just if you divide this 27 by 8, so you divide the 27 by 8, so you will get 3.375. 3.375 means you can write 3.4 and it doesn't have any unit. Therefore you can write it is to be equal to 3.4. That's all. But you must be good at your calculation. That's very important. Okay? It's the problem number 3. Now you study the problem number 4. Come to the problem number 4. The problem is a charge of 25 microcoulomb is placed on the line between the two charges B of 5 microcoulomb and C of minus 30 microcoulomb. The distance of A is 0.05 meter from B and 0.1 meter from C. What is the force on A? You study that problem carefully. He has 3 charges he has placed. So the 25 microcoulomb is placed on the line between the charge of 55 microcoulomb and minus 30 microcoulomb. So he has 3 charges. One is the charge B and other is the charge C. In between he has put the charge A. Then sir, ಹೇಗೆ ಬರೀತೀರಾ ಸರ್ ನೀವು ಅದನ್ನ ತರ? Look, your value of charge A is 25 microcoulomb. It is 25 microcoulomb. And then charge B is 5 microcoulomb. The next value is equal to a charge minus 30 microcoulomb at the point C. Look at the distance he has told. A is at a distance of 0.05 meter. Here from 0.05 meter. Andre it is 5 centimeter anta artha. From C it is 0.1 meter. Illinda 0.1 meter. 0.1 meter ಅಂದ್ರೆ 10 centimeter. ನೋಡಿ ಅರ್ಥ ಆಯ್ತಾ? ಇಲ್ಲಿಂದ ಇಲ್ಲಿವರೆಗೆ 10 centimeter, ಇಲ್ಲಿಂದ ಇಲ್ಲಿವರೆಗೆ 5, ಟೋಟಲಿ 15 ಆಗೋಗಿರುತ್ತೆ. ಅದಕ್ಕೋಸ್ಕರ I have written this charge close to B. ನಿಮ್ಮ ಡೌಟ್ ಬರ್ಬೋದು, ಸರ್ ಇನ್ ಬಿಟ್ವೀನ್ ಯಾಕೆ ಬರಿಬಾರ್ದು, ಇಲ್ಲಿ ಪಕ್ಕದಲ್ಲಿ ಯಾಕೆ ಬರಿಬಾರ್ದು? ಸರಿಯಾಗಿ ಡಿಸ್ಟೆನ್ಸ್ ನೋಡಿ. A is at a distance of 0.05 5 centimeter ದೂರದಲ್ಲಿದೆ. ಇದು 10 centimeter ದೂರದಲ್ಲಿದೆ. ಈ ಕೇಳ್ತಾ ಇರೋದೇನು ಅಂತಂದ್ರೆ ವಾಟ್ ಈಸ್ ದ ನೆಟ್ ಫೋರ್ಸ್ ಆನ್ ಎ. ಈ ಎ ಮೇಲ್ಗಡೆ ವಾಟ್ ಈಸ್ ದ ರಿಸಲ್ಟೆಂಟ್ ಫೋರ್ಸ್ ಅಂತ. ತುಂಬಾ ಚೆನ್ನಾಗಿ ಜ್ಞಾಪಕ ಇರಬೇಕು. ಈ ಪ್ರಾಬ್ಲಮ್ ಕೂಡ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್, ತುಂಬಾ ಸಿಂಪಲ್ ಪ್ರಾಬ್ಲಮ್ ಇದೆ. ಓಕೆ, ಫಸ್ಟ್ ನೀವೇನ್ ಮಾಡಬೇಕು, ಯಾವಾಗ್ಲೂ ಈ ತರ ಪ್ರಾಬ್ಲಮ್ಸ್ ಗಳನ್ನೆಲ್ಲ ಕೊಟ್ಟಾಗ ಅದನ್ನ ನೇಮಿಂಗ್ ಮಾಡ್ಕೋಬೇಕು. ಏನಪ್ಪಾ ಅಂತಂದ್ರೆ ಚಾರ್ಜ್ ಅಟ್ ಎ ಇಸ್ ಈಕ್ವಲ್ ಟು ಕ್ಯೂ ಎ which is 25 microcoulomb and it is 25 into 10 to the power minus 6 coulomb. Charge at B is equal to QB which is 5 microcoulomb. It is 5 into 10 to the power minus 6 coulomb. And charge at C is equal to minus 30 microcoulomb which is minus 30 into 10 to the power minus 6. Okay. Regarding the distance he has told that AB is equal to 0.05 meter and your BC is equal to 0.1 meter. Now they want the resultant force. Look, it's a very simple problem. I used to say ಈ ಎ ಮತ್ತೆ ಬಿ ಇದೆಯಲ್ಲ, ಇವೆರಡರ ಮೇಲೆ ಯಾವ ಫೋರ್ಸ್ ಇದೆ ಅಂತಂದ್ರೆ ನೋಡಿ, ರಿಪಲ್ಸಿವ್. ಇದು ಪಾಸಿಟಿವ್ ಫೋರ್ಸ್, ಇದು ಪಾಸಿಟಿವ್ ಫೋರ್ಸ್, ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್. therefore they will have a repulsive force. ಅವಾಗ ಏನ್ ಮಾಡಿ, therefore the force between charges at A and B ಏನ್ ಬರೀತೀರಾ, FAB ಅಂತ ಬರೀರಿ. FAB is equal to ಏನಾಗುತ್ತೆ, ಅಪ್ಲೈ ದ Coulomb's inverse formula 1/4 pi epsilon naught into Q1 Q2 ಅಂದ್ರೆ QA QB by distance between them, that is equal to AB whole square. Okay, now you substitute those things. Therefore your value would be, it is 9 into 10 to the power of 9. QA is equal to how much? Therefore it says, and your value I can write it in the next step, and therefore so your 1/4 pi epsilon naught value is equal to 9 into 10 to the power of 9. QA value is equal to, it is 25 into 10 to the power of minus 6. QB value is equal to 5 into 10 to the power of minus 6 whole divided by your AB is equal to 5 into 10 to the power of minus 2 whole square. That you can write it like this. Now therefore you simplify this. Your FAB is equal to, now first you rearrange these terms, that is 9 into 25 into 5 into, look at this, minus 6 minus 12, and here is a plus 9, and therefore in the numerator it is minus 3. In the denominator, 5 square ಎಷ್ಟಾಗುತ್ತೆ 25 into 10 to the power of minus 4. 25 get cancelled. Now, you know that this value is equal to 9 into 5 is equal to 45. Here you will get one more 10, and therefore it is equal to 450 Newton. That's all. Therefore your FAB is equal to 450 Newton, and it is acting along ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಆಕ್ಟ್ ಆಗುತ್ತೆ ನೋಡಿ. ಎ ಮತ್ತೆ ಬಿ ಇಬ್ರು ಫೈಟ್ ಮಾಡ್ತಾ ಇದ್ದಾರೆ ನೋಡಿ. ಬಿ ನೋಡಿ, ಇದು ಬಿ ಅಂಡ್ ಎ, ಯುವರ್ ಎ ಇಸ್ ಸ್ಟ್ರಾಂಗರ್. ಎ ಇಸ್ ಸ್ಟ್ರಾಂಗರ್ ಅಂದ್ರೆ ಏನ್ ಮಾಡ್ತಾನೆ? he pushes the B away, ಅಂದ್ರೆ this is FAB. away ಅಂದ್ರೆ along AB, ಗೊತ್ತಿರಬೇಕು, along AB. that's all. ಅರ್ಥ ಆಯ್ತಾ? ಇದು ಫೋರ್ಸ್ ಬಿಟ್ವೀನ್ ಎ ಅಂಡ್ ಬಿ. ನಮ್ಗೆ ಕೇಳ್ತಾ ಇರೋದು ನೆಟ್ ಫೋರ್ಸ್ ಆನ್ ಎ. now you calculate the force between the charges at A and C. That's equal to FAC. FAC is given by 1 by 4 pi epsilon naught. It is QA, QC, and it is equal to AC whole square. So you will substitute ಮಾಡಿ, and this value is equal to 9 into 10 to the power of 9, 25 into 10 to the power of minus 6, and this value is equal to minus 30 into 10 to the power of minus 6 whole divided by this value is equal to 0.1. 0.1 for your calculation you can read as 1 by 10. Now it is 9 into 25 into 30 with a minus sign. It indicates that there is an attractive force, and here this is minus 6, and this is 1 by 100 that comes to numerator. Okay, these two zeros along with this zero, and it gets cancelled, minus, it is equal to, if you calculate, it comes out to be 675 Newton. FAC is equal to 675 Newton. How it is acting along? It is acting along ನೋಡಿ, ಎ ಅಂಡ್ ಸಿ ನಡುವೆ ಏನಿದೆ? ಅಟ್ರಾಕ್ಟಿವ್ ಫೋರ್ಸ್ ಇದೆ. ಅಟ್ರಾಕ್ಟಿವ್ ಇದ್ರೆ ಎ ಗಿಂತ ಸಿ ಸ್ಟ್ರಾಂಗ್ ಆಗಿರೋದ್ರಿಂದ ಏನಾಗುತ್ತೆ? ಇಟ್ acts in this direction. FAC acts in this direction. So it is acting along AC. Therefore you can call it as acting along AC. ನೀವೇ ಯೋಚನೆ ಮಾಡಿ, ಈ ಕಡೆಗೆ 675 ನ್ಯೂಟನ್, ಈ ಕಡೆಗೆ 450 ನ್ಯೂಟನ್. ನೋಡಿ, 675 and 450. And net force is acting in the direction of the greater force, and therefore the resultant force on A is, you know that your F is equal to FAB plus FAC. FAB is equal to 450 Newton plus 675 Newton. That comes out to be minus 225 Newton. Very important. 6 minus 225 Newton. And how this force is acting on? This force is acting along. It is acting along BAC ಅಂತ ಹೇಳಬೇಕು. It is AC ಹೌದು, but complete ತಗೊಂಡ್ರೆ it is equal to acting along BAC. ಈ ಕಡೆ ಆಕ್ಟ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಅರ್ಥ ಆಯ್ತಾ? That's the resultant force. It's also very important question for the 5 marks. Okay. So question number 5. Now it's question number 4 is over. We shall take up the question number 5. Study the question carefully. Electric field at a point 0.1 meter from a point charge placed in a medium of dielectric constant 18 into 10 to the power of Newton per Coulomb. Find the magnitude of the static charge. You study the problem once again. The electric field at a point 0.1 meter from a point charge placed in a medium of dielectric constant 9 is 18 into 10 to the power of 3 Newton per Coulomb. Find the magnitude of the charge. See, look. Here is a static charge, which we denoted by capital Q. And here is a point P. This point P is at a distance of 0.1 meter from this charge, he says. Now his question is, what is the value of the charge, and if the electric field is given here, electric field he has given. So it's a very simple problem it is. So he has given the electric field at that point to be equal to 18 into 10 to the power of 3. It is 18 into 10 to the power of 3 Newton per Coulomb. And he has given the dielectric constant to be equal to 9. And he has given the distance to be 0.1 meter. Now his question is, what is the value of Q? What is the value of the static charge? Find the value of Q, static charge. ಇದು ನೋಡ್ತಾ ಇದ್ರೆ ನಿಮಗೆ ಡೈರೆಕ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ವಾ? ಸೊ ನಿಮಗೆ ನೋಡ್ತಿದ್ದಂಗೆ ಅರ್ಥ ಆಗುತ್ತೆ. ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಎಟ್ ಎ ಪಾಯಿಂಟ್ ಡ್ಯೂ ಟು ಐಸೋಲೇಟೆಡ್ ಚಾರ್ಜ್. ಜ್ಞಾಪಕ ಇರಬೇಕು ಇದು. ಫೀಲ್ಡ್ ಡ್ಯೂ ಟು ಐಸೋಲೇಟೆಡ್ ಪಾಯಿಂಟ್ ಚಾರ್ಜ್. That is the formula. Isolated point charge is given by electric field is equal to 1 by 4 pi epsilon naught into epsilon r into it is Q divided by. So this is the capital Q divided by d square. You want to calculate the capital Q. So you substitute as it is. This value is equal to 18 into 10 to the power of 3. This value is equal to 9 into 10 to the power of 9. Your dielectric constant is 9. Q is not known. Your D is equal to 0.1. 0.1 you can write off 1 by 10 whole square. This 9 and 9 get cancelled. Okay. Now what you are left with is your 18 into 10 to the power of 3 is equal to 10 to the power of 9. These two zeros will come here and it is equal to Q. And therefore your Q is equal to, remember, it is 18 only, 10 to the power of 3, and these are 10 to the power minus 11. In the minus 11, so this if you take it here, it is equal to 18 to 10 to the power of 3 into 10 to the power of minus 11. 9 plus 2 is 11. That if you bring it to this side, it becomes minus 11. And therefore your charge would be Q is equal to 18 into 10 to the power of minus 8 Coulomb. That's all. Okay, what's the value of the charge? 18 into 10 to the power of minus 8 Coulomb. If you want, you can make it as a minus 9 or you can leave it as it is. Okay, this is the question number 5. It's very simple problem. Okay, very simple problem. Now we will take the question number 6. Find the separation between the two protons in order that Coulomb repulsive force acting on either of them may be equal to the weight. Given the charge on the proton is equal to 1.6 into 10 to the power minus 19 Coulomb, mass of the proton is given and G is given. Very simple problem. Says find the separation between the two protons. He says here is one proton, Q1. Here is another proton, that is Q2. And find the separation between them. You want to calculate the distance of separation between them. Okay. So you are in order that the repulsive force may be equal to the weight. The repulsive force is equal to the weight. Weight is equal to, remember, this is the formula mg, which you have studied from the first year PUC. Equal to the weight. Given that the charge on the proton is, remember, charge on the proton he has given it as 1.6 into 10 to the power of minus 19 Coulomb. Remember, mass of the proton is given to be, mass of the proton he has given it as, how much? It is equal to 1.67 into 10 to the power of minus 27 kg. Okay, and G value is given to be 9.8. G value is given to be 9.8 meter per second square. What is this problem? You want to calculate that, you want to find the distance of separation between them. Very simple problem it is. Okay, you want to calculate the D. He has not given the force directly. See, it's a very simple thing. He has said these are the two protons, and therefore your Q1 is equal to Q2 is equal to charge on the proton. Both are same. Both are the proton, therefore repulsive force will be there. And he has said the force is equal to mass into acceleration due to gravity. Therefore, you know that from Coulomb's law, you know that your F is equal to 1 by 4 pi epsilon naught into Q1 Q2 by D square. This is a formula. Inverse square. He has given everything. You want to calculate the value of D. Now in the place of F, you must write the value of mg. Okay. Therefore, your mg is equal to 9 into 10 to the power of 9 into, this is E, this is E, because both are the charge in the protons, divided by D square. Now you just interchange this, rearrange. It is D square is equal to 9 into 10 to the power of 9, and it is E square whole divided by mg. Okay, now you can take the square root if you want, and therefore your D is equal to square root of 9 into 10 to the power of 9. So E into E, 1.6 into 10 to the power of minus 19 square. Okay, whole divided by m value is equal to 1.67 into 10 to the power of minus 31 into G value is equal to 9.8. Now you have to simplify these things. Simplification is very important. And your 9 into this is 9 into 1.6 whole square is equal to 2.56 into 10 to the power of minus 38 into 10 to the power of plus 9 whole divided by 1.67 into 9.8 into 10 to the power of minus 31. Now we have rearranged all these things. Now what you have to do is you have to simplify all these things. How simplify ಮಾಡ್ತೀರಾ? 9 into this ಮಾಡಿ ಇದೆರಡು separate ಆಗಿ multiply ಮಾಡಿ. So you will get the value, and your value would be, remember, your 9 into 2.56 you have, and its value is equal to 23.04. It is 23.04 whole divided by, you have 1.67 into 9.8 you have. So that comes out to be equal to 16.37. 16.37. You simplify these things. Look here. Here is minus 31. Here minus 31 goes off. And you are just left with how much? It's equal to, in the 38, if 31 goes, you are left with a 7, plus 7. And here is plus 9, and you have 10 to the power of 2. Now you simplify these two. Therefore, you are 23.04 divided by 16.37. If you simplify this one, that comes out to be 1.40. So this comes out to be 1.407 into, this is 10 square. Now you take a root for this one. You take one, that is equal to 1.186. This is 1.186. And you know that this value is equal to 10, which comes out to be 11.86 meter. This is the distance of separation between them. Once again, you check the calculation of this one, okay? It's a very simple thing, but every time what you have to do is, you have to be very good at the calculation, and you must check the calculation always, okay? And somewhere we have gone wrong, and it appears that we have gone wrong elsewhere. Somewhere we have gone wrong, and it is m is equal to 1.67 into, I have written this as a minus, this is minus 27, okay? Not 31, that's a charge on that. And therefore it is equal to minus 27, and therefore your value would be minus 27, and here is minus 11 you are left with, and it will go minus 2, and that's equal to, the value finally would be, this is minus 1, if you bring it, this is minus 1, and which comes out to be equal to 1.186. Okay, minus 27, and there you are minus 38 plus 9 is there, and that comes out to be equal to 1.186. I think your calculation is right. It seems to be. It is 1.41, 1.407, and that 1.407, if you take it as a root, it is equal to 1.18 divided by 10 to the power minus 1.186 meter, or which you can call it as 0.12 meter. Therefore, you should write the answer at the end. The distance between the protons is 0.12 meter. Yes. So 4 into 10 to the power of minus 5 Newton. Charge on one sphere is twice the charge on the other. When they are moved 0.2 meter further apart, the force is reduced to 10 into 10 to the power minus 6 Newton. What are the charges and what was the initial separation between them? You study this problem carefully. He says that two small spheres are charged so that they repel each other. Here are the two small spheres. The charge on them is equal to Q1, Q2, and D is the separation between them. D is the distance of separation between them. Okay. Then he says that there is a repulsive force of, between those two charges, there is a repulsive force of 4 into 10 to the power of minus 5 Newton. You study the step one by one. The charge on one sphere is twice the charge on the other. Therefore, your Q2 is equal to 2 into Q1. That is, charge on the one sphere is twice the charge on the other sphere. Then what he says? When they are moved 0.2 meter further apart. This is the initial separation. Now he moves by another 0. This Q he moves to 0.2 meter further apart. ಇನ್ನು ಸ್ವಲ್ಪ ಮುಂದೆ ಆಗ್ತಾನೆ ಹೀಗೆ. ಅವಾಗ ನೋಡಿ ಏನಾಗುತ್ತೆ, what is the distance? The final distance between them is equal to your D1 is equal to D plus 0.2 meter ಅಲ್ವಾ? ಟೋಟಲ್ ಡಿಸ್ಟೆನ್ಸ್ ಅವಾಗ ಇಲ್ಲಿಂದ ಇಲ್ಲಿವರೆಗೆ ಡಿಸ್ಟೆನ್ಸ್ ಏನಾಗುತ್ತೆ? D plus 0.02. Then what he says? Because he has moved further away, force decreases. He says force decreases. Then what is the new force? The new force F1 is equal to, the value is equal to, he says, 10 into 10 to the power of minus 6 Newton. Naturally, you notice that the force decreases when the distance increases. Okay. Then, what are the charges? He says, what are the charges? Q1 and Q2. Calculate the value of Q1, calculate the value of Q2, and even the distance between them also you calculate it. Problem is clear, I think it is. Look, initially there was a separation of D. Force was this much. Charge on one is twice the charge on the other. When it is moved 0.2 meter apart, the force decreases to this much. Then he says, what was the charge on this and what is the separation? I think you can solve this very from Coulomb's law. You should say it is from Coulomb's law. So from Coulomb's law, the force between them is given by your F is equal to 1 by 4 pi epsilon naught into Q1 Q2 divided by D square. Okay, this is F, which you can call it as equation number 1. When he moves it further away, you know that when moved away, when moved by 0.2 meter, the force is F1 1 by 4 pi epsilon naught into Q1 Q2 by, this is the D1 square. It is not D. Now the new distance is equal to D1. Remember that. This is the D1. Equation number 2. You divide one by the other. Divide equation 1 and 2. You know that. You have got everything here. All these things get cancelled. F and D are inversely related, and therefore you divide equation 1 and 2. Divide equation 1 and 2. What you are going to get then? Your F by F1 is equal to D1 square divided by D square. What is the value of? It's equal to D 0.02 whole square. This is D square. Look at this. Now, you substitute those values. What is the value of F? F is equal to 4 into 10 to the power of minus 5. This is 10 into 10 to the power of minus 6. That's equal to, you put a D plus 0.2 divided by D. You put a single square on them. Okay? Every square idea. Even note. Here minus 5 is minus 1 is it comes to the numerator. Therefore, it is equal to 40 by 10. Is equal to D plus 0.2 divided by D. So, you take a root of that. It's cancelled. Okay? And therefore, what's the root of 4 is equal to? It is 2. It is 2 is equal to D plus 0.2 divided by D. Therefore, your 2D is equal to D plus 0.2 and 2D minus D is equal to D. That's equal to 0.2 meters. Okay, this is the initial separation. That's equal to 0.2 meter. Okay, now what you have to calculate? You have to calculate the Q1 and Q2. Yen madi. Substitute this value of D in any one of the equation, either equation 1 or equation 2. Therefore, you say that substitute value of D is equal to 0.2 meter in equation 1 like. Avaga F is equal to 1 by 4 pi epsilon naught into Q1. Q2 is equal to, look at this, Q2 is equal to 2 into Q1. In the place of Q2, you write 2 into Q1 divided by the distance square. That's all. You know everything, you know the value of this F. So therefore your F is equal to 4 into 10 to the power of minus 5 and that's equal to value of this 9 into 10 to the power of 9 and this is 2 into, here it is Q1 into Q1 is nothing but the 2 into Q1 square whole divided by D as you have calculated 0.2 can be written as 2 by 10. Okay, now it's very easy now and therefore it is equal to 4 by 9, you bring that here, 10 to the power of minus 5 and this will come as a minus 9. Okay, when I bring it here it will be a minus 9. That should be equal to 2 into Q1 square whole divided by 4 by 100. Okay, it is 2 ones are 2 twos are. You bring the 2 here, therefore it becomes 8 by 9 into 10 to the power of minus 14 and you are getting 1 more 2 there and therefore it is equal to Q square if I bring it here. Now therefore what is its value? Your Q1 is equal to square root of 8 by 9 into 10 to the power of minus 16. You simplify that value of 8 by 9. Okay, so you know that the value of 8 by 9 is nothing but it is equal to, so you divide 8 by 9 and 0.88 you will get. Okay, this value would be, remember, 0.888. Now you take the root for this one. which comes out to be 0.94. It comes out to be 0.94 into 10 to the power of minus 8 Coulomb. And therefore your Q1 is equal to 9.4 into 10 to the power of minus 9 Coulomb, which is nothing but Q1 is equal to 9.4 nanocoulomb. Nanocoulomb, because minus 9. So you got the value of Q1. What is the value of Q2? Substitute this in the equation number that is there. Your Q2 is equal to 2 into Q1. 2 into Q1 is 9.4, and therefore this comes out to be 18.8 nanocoulomb. So what you have calculated? He wanted the value of D. You have calculated the Q1 and Q2, and therefore you write Q1 is equal to 9.4 nanocoulomb and Q2 is equal to 18.8 nanocoulomb and D is equal to 0.2 meter. You put a box for this. This is your final answer. You write the equation number 1, then the equation number 2. You directly divide because everything is there as it is, okay? Except D1, except D, everything is a constant, and you divide that, you will get the value of D. And other substitute this value in any one other simpler equation, so you will get the value of the Q1, okay? Very simple thing. If B is equal to 90 degree and the value of AB is equal to 3 centimeter, AC is equal to 2 centimeter, BC is equal to 1 centimeter, find the resultant electric field both in magnitude and the direction. Very simple and very important, okay? See here, he has 2 point charges and he has ABC, a right angled triangle. Here is a right angled triangle. So your ABC is a right angled triangle with angle B is equal to 90 degree. Again, he has placed 2 charges. One is minus 4 microcoulomb and another is plus 2 microcoulomb at the corners A and C. And he says that the value of AB is equal to 3 centimeter. This is 3 centimeter. And he says AC is equal to 2 centimeter. He says BC is equal to 1 centimeter. Then what do you want? Find the resultant field both in magnitude and the direction at the corner B. Remember, at the corner B. You want to calculate the resultant field. Very important. How will you calculate this? I think you have understood the problem. You have 2 charges at A and C. You want to calculate the resultant field at the point B. ನೋಡಿ ಈಗ ಇಲ್ಲಿ ಹೇಗೆ ಇದನ್ನು ಯೋಚನೆ ಮಾಡಬೇಕು ಅಂದ್ರೆ, ಸೊ ಇಲ್ಲಿ ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಅನ್ನ ಇಟ್ಟಿದ್ರೆ ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ ಇದು ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಅಲ್ವಾ. ಇದೇನ್ ಮಾಡುತ್ತೆ ಅಂದ್ರೆ ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಅನ್ನ ಈ ಕಡೆಗೆ ಅಟ್ರಾಕ್ಷನ್ ಮಾಡುತ್ತೆ. ದ ಫೀಲ್ಡ್ ಎಟ್ ದಿಸ್ ಪಾಯಿಂಟ್ ಈಸ್ ಈವನ್ and that field is attracted towards this one, okay? ಇದು ನೋಡಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದೇನ್ ಮಾಡುತ್ತೆ, ಇದನ್ನ ರಿಪೆಲ್ ಮಾಡುತ್ತೆ. ರಿಪೆಲ್ ಮಾಡೋದ್ರಿಂದ ಫೀಲ್ಡ್ ಈಸ್ ಆಕ್ಟಿಂಗ್ ಇನ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್, ದಟ್ ಈಸ್ E2. ನಾನು ಅದಕ್ಕೆ ನಿಮ್ಗೆ ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳೋಕೆ ಪ್ಯಾಂಟ್ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೆ. ಪ್ಯಾಂಟ್ ಅಂತಂದ್ರೆ ಅರ್ಥ ಏನು ಅಂತಂದ್ರೆ, ಪ್ಯಾಂಟ್ ಹಾಕೋದಂದ್ರೆ ಇದು ಇಲ್ಲಿ ನೋಡಿ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇದೆ, ಇಲ್ಲಿ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದೆ. ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದ್ರೆ ಫೀಲ್ಡ್ ಈಸ್ ಅವೇ, ಅದೇ ಅರ್ಥ ನೋಡಿ. ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದ್ರೆ ಫೀಲ್ಡ್ ಈಸ್ ಅವೇ. ನಿಮ್ಮ ಡೈರೆಕ್ಷನ್ ಇಂಪಾರ್ಟೆಂಟ್. ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇದ್ರೆ ಫೀಲ್ಡ್ ಈಸ್ ಡೈರೆಕ್ಟೆಡ್ ಟು, ನೋಡಿ ಇಲ್ಲೂ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಇದ್ರೆ ಫೀಲ್ಡ್ ಹಿಂಗ್ ಬಂದಿರೋದು. ಅರ್ಥ ಆಯ್ತಾ? ಇಲ್ಲಿ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇದೆ, ಫೀಲ್ಡ್ ಈಸ್ ಡೈರೆಕ್ಟೆಡ್ ಟುವರ್ಡ್ಸ್, ಅದೇ ಅರ್ಥ. NT ಅಂದ್ರೆ ಅದೇ ಅರ್ಥ. ಅವಾಗ ನಿಮ್ಮ ರಿಸಲ್ಟೆಂಟ್ ಫೀಲ್ಡ್ ಏನ್ ಬರುತ್ತೆ ಅಂತಂದ್ರೆ ದಿಸ್ ಇಸ್ ದ ರಿಸಲ್ಟೆಂಟ್ ಫೀಲ್ಡ್ ಅಷ್ಟೇ. ಇದು ಕಂಡಿಡಿಬೇಕು. ಹೇಗೆ ಕಂಡಿಡ್ತೀರಾ? ಫಸ್ಟ್ ಡೇಟಾ ಬರೀರಿ. ಡೇಟಾ ಏನಿದೆ, he has given QA. QA is equal to minus 4 microcoulomb, minus 4 into 10 to the power of minus 6 And he has given the value of QC, which is 2 microcoulomb, which is 2 into 10 to the power minus 6 coulomb. And he has given the values of AB 3 centimeter. You require that you convert it into the meter as 3 into 10 to the power minus 2 meter. You want this BC, which is 1 centimeter. You convert it into this one, 1 into 10 to the power minus 2 meter. Now he wants the resultant fields. Therefore, what you have to find is, you have to find the resultant field, that is E. And even this angle you have to calculate, that is alpha. So how will you work it out? First you calculate the field at B due to this one, which we call it as a E1. Okay. Therefore, field at B due to the charge at A is, your E1 is equal to 1 by 4 pi epsilon naught into, it is QA divided by distance is equal to AB whole square. Therefore, this value is equal to 9 into 10 to the power of 9. This value is equal to minus 4 into 10 to the power of minus 6 whole divided by value of AB is equal to 3 centimeter, which is 3 into 10 to the power minus 2 whole square. Okay. So you have substituted all these things. Okay. So you have substituted those things. Now you continue with the calculations. 4 into minus this is equal, this is 9 into 4 into 10 to the power of plus 3. You have got 9 into 10 to the power of minus 4. 9 and 9 get cancelled. And therefore your value would be minus of 4 into 10 to the power of minus 7. Remember, your E1 is equal to minus of 4 into 10 to the power of minus 7 Newton per Coulomb. And it is acting along BA. Acting along BA. Very important. As a you calculate the field at B due to this charge. You calculate matter of field at B due to the charge A. Now field at B due to the charge at C. Therefore, the field at B due to the charge at C, that's given by E2 is equal to 1 by 4 pi epsilon naught into, it is QC divided by BC whole square. So ನಿಮಗೆ ಗೊತ್ತಿದೆಯಲ್ಲ formula 1 by 4 pi epsilon naught into Q by D square. That is the formula, generalized formula. Your generalized formula is E is equal to 1 by 4 pi epsilon naught into Q by D square is the formula for this one. Okay. So you substitute all these things, and this value is equal to 9 into 10 to the power of 9. Your QC is equal to 2 into 10 to the power of minus 6 divided by 10 to the power of minus 2 whole square. You know that this value would be 9 into 2 is equal to 18. 10 to the power of plus 3 here. And here is a minus 4 that comes to the numerator as plus 7. And so much of Newton per Coulomb. And it is acting along CD. Acting along CD, E direction barutte. This is the value of E2. Okay. So we have calculated the E1 and we have calculated the E2, and here minus 4 will come as a plus 4, and it's also 7. This is also 7. So we have calculated E1, we have calculated E2. Look, here this angle theta is equal to 90 degree, it is there. That you must know, when theta is equal to 90, cos 90 is equal to 0. You want to calculate the resultant electric field. You look at the first year PU syllabus where you know that the resultant field is given by, the field is given by, for the formula, E is equal to square root of E1 square plus E2 square plus E1 E2 into cos theta. So therefore, your resultant field is equal to square root of E1 ಅಂತಂದ್ರೆ ಎಷ್ಟಿದೆ ಅದು 4 into 10 to the power of 7. It is 4 into 10 to the power of 7 whole square plus 18 into 10 to the power of 7 whole square. And this term, look at this term, the term becomes 0. Why it becomes 0? You can say that since theta is equal to 90, cos 90 is equal to 0, and therefore this whole term is equal to 0. Okay, therefore your value would be 4 into 4 is equal to 16 into 10 to the power of 14 it is. Okay, so it is 324 into 10 to the power of 14. You take the 10 to the power of 14 as a common factor, and therefore your 16 plus 324 into 10 to the power of 14, that comes out to be equal to root of 324 plus 16 is equal to root of 340 into 10 to the power of 14. You take the root of 340, take a root for that, which comes out to be 18.43, and that's equal to 18.43 into 10 to the power of 7 Newton per Coulomb. This is the resultant electric. Can you follow this? Now you want to calculate the direction. What is the formula for the calculate the direction? Remember, to find the direction, your formula is tan alpha is equal to, original formula is q sin theta divided by p plus q cos theta. First year PUC littala ade formula. Okay, illi p antandre, so ನೀವೇನಂತ ತಗೊಳ್ಳಿ, it is q sin theta, p and q. This you take it as a p, this you take it as a q. Therefore I am applying this one, and this is equal to e2 sin theta divided by e1 plus e2 cos theta. Therefore your tan alpha is equal to, when theta is equal to 90, you know that the sin 90 is equal to 1. Remember that. Therefore your value would be 18 into 10 to the power of 7 into sin 90 whole divided by p value is equal to 4 into 10 to the power of 7. Don't take the negative sign, it is not needed. And your E2 is equal to 18 into 10 to the power of 7 into cos 90. You know that the cos 90 degree is equal to 0. Sin 90 is equal to 1. What you are getting is 18 into 10 to the power of 7, 4 into 10 to the power of 7, because this term vanishes to 0. Cos 90 is equal to 0. 10 to the power of 7 also get cancelled. ಎಷ್ಟಾಗುತ್ತೆ ಆವಾಗ? If you divide by that, that becomes 9 by 2. Again, if you divide that, that becomes 4.5. Therefore, your tan alpha is equal to 4.5, which implies your alpha is equal to tan inverse of 4.5. Now, in your natural tangent, you search for 4.5. You do not have the exact value of 4.5. But you must search for the nearest to the 4.5. Look, 4.5000 you should search for. See, look, you have got 4.5107 in 77 degree 30 minutes. So it is 77 degree 30 minutes. Till value ಯಾವುದು ಬರುತ್ತೆ ಅಂತಂದ್ರೆ 4.5107. ಅದಷ್ಟಕ್ಕೆ ನೋಡಿ, ಪರವಾಗಿಲ್ಲ. You do not have the exact value, and it is 77 degree 30 minutes. Okay. So you remember this. Here is a rectangle to triangle. Your problem is very easy because theta is equal to 90 means cos 90 vanishes. You calculate the field at the result at the field at this point due to this charge, and field at this point due to this charge, and resultant field acts in this direction. That's the resultant field. Okay. That's the magnitude. If you want to calculate the direction, that's the value. Okay. So very simple thing. You follow these problems. Study the next question carefully. The electric intensity in the region between pair of oppositely charged parallel conducting plates of area 1 square meter is 10 to the power of 4 volt per meter. So, in the question number 9, ಎರಡು ಪ್ಲೇಟ್ಸ್ ಇದ್ದಾವೆ. ಅದರದ್ದು ಏರಿಯಾ ಕೊಟ್ಟಿದ್ದಾನೆ. He has given the electric field. ಅಲ್ಲೇನೋ ಒಂದು electric field ಇದೆ ಅಂತ he has given the value of the electric field. What is the charge on each plate ಅಂತ ಕೇಳ್ತಾರೆ. ಚೆನ್ನಾಗಿ ಜ್ಞಾಪಕ ಇರಲಿ, ಇಲ್ಲಿ ಏನೋ ಕೊಟ್ಟಿದ್ದ ಅವನು ಅಪೋಸಿಟ್ ಚಾರ್ಜ್ ಪ್ಲೇಟ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಕೊಟ್ಟಿದ್ದಾನೆ. ವಾಟ್ ಇಸ್ ದ ಚಾರ್ಜ್? ಲುಕ್, ಇದು ಕಾನ್ಸೆಪ್ಟ್ ಏನು ಅಂತಂದ್ರೆ ಬಿಟ್ವೀನ್ ಎ ಪೇರ್ ಆಫ್ ಅಪೋಸಿಟ್ಲಿ ಚಾರ್ಜ್ ಪ್ಲೇಟ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇಸ್ ಗಿವನ್ ಬೈ ದ ಫಾರ್ಮುಲಾ ಸಿಗ್ಮಾ ಬೈ ಎಪ್ಸಿಲಾನ್ ನಾಟ್ ಅಂತ ಫಾರ್ಮುಲಾ ಇದು. ಬಟ್ ಇದು ಸಿಲೆಬಸ್ ಅಲ್ಲಿ ಇಲ್ಲ ಅಂತ ಅನ್ಕೋಬೇಡಿ, ಬೇಕಾಗತ್ತೆ ಅದು ಸಿಗ್ಮಾ ಬೈ ಎಪ್ಸಿಲಾನ್ ನಾಟ್. ಬಟ್ ಸಿಗ್ಮಾ ಇಸ್ ಈಕ್ವಲ್ ಟು ನಿಮ್ಗೆ ಗೊತ್ತಿದೆಯಲ್ಲ ಕ್ಯೂ ಬೈ ಎ. ಓಕೆ, therefore this is ನಿಮ್ಗೆ ಏನ್ ಬೇಕು ಈಗ? ಕ್ಯೂ ಬೇಕು. ಯುವರ್ ಕ್ಯೂ ಇಸ್ ಈಕ್ವಲ್ ಟು ಇ ಇಂಟು ಎ ಇಂಟು ಎಪ್ಸಿಲಾನ್ ನಾಟ್. E value he has given. How much the value of E value he has given it as 10 to the power of 4 volt per meter. Area he has given it as 1 square meter. And value of epsilon naught is 8.854 into 10 to the power minus 12. Therefore, that comes out to be 8.854 into 10 to the power of minus 8 Coulomb. That's all the charge on this. Okay, ಚೆನ್ನಾಗಿ ಗೊತ್ತಿರಲಿ ಇದು. Electric field between the pair of oppositely charged plate is equal to so much, and you know that the surface charge density is given by the formula Q by A, charge by area. He has given everything, and look what he has given. He has given the electric field 10 to the power of 4 volt per meter. He has given the area as 1 meter square, and he has asked you to calculate the Q. Next, you take up the problem number 10. What's the problem number 10? Find the maximum charge that can be held on a metal sphere of diameter 60 millimeter. Metal sphere ಇದೆ, radius is capital R. ಇದ್ರ ಮೇಲ್ಗಡೆ ಚಾರ್ಜ್ ಇದೆ. ಕೇಳ್ತಾ ಇದ್ದಾನೆ find the maximum charge that a sphere can hold. And the diameter is equal to 60 millimeter. ಅದರ ಅರ್ಥ radius is equal to 30 millimeter, which implies your radius is equal to 30 into 10 to the power minus 3 meter, or that we call it as 3 into 10 to the power minus 2 meter. ಇವೆಲ್ಲ ಕನ್ವರ್ಷನ್ ಚೆನ್ನಾಗಿ ಗೊತ್ತಿರಬೇಕು. That it can hold surrounded by air of dielectric strength is. Dielectric strength ಅಂದ್ರೆ ಚೆನ್ನಾಗಿ ಜ್ಞಾಪಕ ಇರಬೇಕು. ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ 33 into 10 to the power of 6 volt per meter. ಚೆನ್ನಾಗಿ ಜ್ಞಾಪಕ ಇರಬೇಕಲ್ಲಿ. ನಿಮ್ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಸ್ಟ್ರೆಂತ್ ಅಂತ ಬಂದ್ಬಿಡುತ್ತೆ. ಏನಿದು ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಸ್ಟ್ರೆಂತ್ ಅಂತ ಅಂದ್ರೆ ಜ್ಞಾಪಕ ಇರಬೇಕು. ದಟ್ಸ್ ದ ಮ್ಯಾಕ್ಸಿಮಮ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ರಿಕ್ವೈರ್ಡ್ ಟು ಕಾಸ್ ಎ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಪಂಚರ್ ಅಂತ ಬರುತ್ತೆ, ನಾವೇ ಹೇಳೋಣ. ಬಟ್ ಚೆನ್ನಾಗಿ ಗೊತ್ತಿರಲಿ, ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಯೂನಿಟ್ ನೋಡಿ ಯಾರು ಚೆನ್ನಾಗಿ ಕಲ್ತಿರ್ಬೇಕಿದ್ರು. ಏನ್ ಕೇಳ್ತಾ ಇರೋದು? ಈ ಸ್ಪಿಯರ್ ಎಷ್ಟು ಚಾರ್ಜ್ ಹಿಡ್ಕೊಳತ್ತೆ ಅಂತ. You know that the electric field on the sphere is given by E is equal to 1 by 4 pi epsilon naught into Q by R square ಅಂತ ನಿನ್ನೆ ಗಾಸ್ ಥಿಯರಮ್ ಮಾಡಿದಾಗ ಹೇಳಿದ್ದೆ. E ಕೊಟ್ಟಿದೆ, ಎಲ್ಲ ಕೊಟ್ಟಿದೆ, Q ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. You want to calculate that Q, and therefore ಚೆನ್ನಾಗಿ ಜ್ಞಾಪಕ ಇರಬೇಕು. Therefore your Q is equal to E into 4 pi epsilon naught into R square. The value of E value is equal to 33 into 10 to the power of 6. What is the value of 1 by epsilon naught? 9 into 10 to the power of 9. As the denominator in the numerator is the denominator. 10 to the power of, that is value of R is equal to 3 into 10 to the power of minus 2 whole square. Clean and simplify ಮಾಡಿ. Therefore this Q comes out to be equal to ಎಲ್ಲಡೆ. Therefore rearrange the term. 33 divided by 9 ಇಲ್ಲಿ ನೋಡಿ, ಇಲ್ಲಿ 3 square is equal to 9. ಪವರ್ಸ್ ನೋಡಿ, ಇಲ್ಲಿ 6, ಇಲ್ಲಿ 9, ಇಲ್ಲಿ -4. Therefore 10 to the power of 6, 10 to the power of -4, 10 to the power of 9. Cancel ಆಯ್ತು. 33 into 10 to the power of, ಇಲ್ಲಿ ನೋಡಿ 6 ಇದೆ, 9 ಇದೆ, 3 ಉಳಿಯುತ್ತೆ, ಮೇಲ್ಗಡೆ ಬಂದ್ರೆ -7 Coulomb. That's all. ಅರ್ಥ ಆಗಿದೆಯಾ? ಬಹಳ ಇಂಪಾರ್ಟೆಂಟು, ಚೆನ್ನಾಗಿ ಗೊತ್ತಿರ್ಬೇಕು ಇವೆಲ್ಲ. ಓಕೆ, ಕ್ವಶನ್ ನಂಬರ್ 10 ಕೇರ್ಫುಲಿ. 2 identical pith balls, each of mass 10 milligrams, hung from a single support by strings of equal length 0.4 meter. So here are the 2 balls hung from a rigid support by 2 inextensible threads, and they are suspended by a string of equal length 0.4 meter. When the charges are given the same quantity, when these balls are given the same quantity of charge, so when they are given same quantity of charge, you know that they repel each other and get separated by a distance of 0.1 meter. Average distance ಎಷ್ಟಾಗುತ್ತೆ? 0.1 meter. And come to equilibrium with 30 degree between them. Find the charge on each ball. So ಇವೆರಡರ ನಡುವೆ 30 degree ಬರುತ್ತಂತೆ. Find the charge on each ball. ಕರೆಕ್ಟ್ ಆಗಿ ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳಿ, ಪ್ರಾಬ್ಲಮ್ ನ ಸರಿಯಾಗಿ ಓದಿ. ಏನ್ ಹೇಳ್ತಾ ಇದ್ದಾನೆ? Here are the 2 balls, they are charged with Q and each side is 0.4 meter. When they are given equal amount of charge, they repel each other. ಇದನ್ನ ಈ ಕಡೆಗೆ ರಿಪೆಲ್ ಮಾಡುತ್ತೆ, ಇದು ಈ ಕಡೆಗೆ ರಿಪೆಲ್ ಮಾಡುತ್ತೆ. ಜ್ಞಾಪಕ ಅಲ್ಲೇ, that's called repulsive force. ಅವಾಗ ಎರಡರ ನಡುವೆ ಡಿಸ್ಟೆನ್ಸ್ ಎಷ್ಟಿರುತ್ತೆ? 0.1 ಮೀಟರ್. ಇದು ರಿಪೆಲ್ ಆಗಿ ಈ ಆಂಗಲ್ 30 ಡಿಗ್ರಿ ಆಗುತ್ತೆ. ಈಗ ಕೇಳ್ತಾ ಇದ್ದೇನೆ, ವಾಟ್ ಇಸ್ ದ ಚಾರ್ಜ್? ಹೆಂಗ್ ಸರ್ ಮಾಡೋದು ನೋಡಿ. ಇಲ್ಲಿ ಫಸ್ಟ್ ಇದು ನೋಡ್ತಾ ಇದ್ದಂಗೆ ಅರ್ಥ ಆಗುತ್ತೆ. ಫೋರ್ಸ್ ಆಫ್ ರಿಪಲ್ಷನ್ ಕೊಟ್ಟಾಗ ಯು ಶುಡ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ Coulomb's inverse square law. ಸೊ ನಾವೇನ್ ಬರೀಬೇಕು? ಫ್ರಮ್ Coulomb's law, the force between the charges is given by force F is equal to 1 by 4 pi epsilon naught into Q1 Q2 divided by Q1 Q2 divided by D square. ನಿನಗೆ ಬೇಕಾಗಿರೋದು what is the charge on each ball. Therefore your F is equal to 9 into 10 to the power of 9 by D square into Q square. Therefore your Q is equal to square root of Q ಬೇಕು F into D square whole divided by 9 into 10 to the power of 9. That you take it as equation number 1. You know the value of D, you want to calculate the F. Hex or F calculate ಮಾಡೋದು. Remember he says each ball is in equilibrium. ಎರಡು equilibrium ಇರುತ್ತೆ, ಒಂದ್ರ ಬಗ್ಗೆ ಮಾತ್ರ ಬರೆಯೋಣ. ಯಾವ್ದೇನ್ ಮಾಡಿ equilibrium ಬೇಕಾದ್ರೆ 3 force act ಆಗ್ತಾ ಇರುತ್ತೆ. One is weight, W is equal to mg acting in the downward direction, repulsive force in this direction, tension in this direction. You know in the first year PUC I have taught the Lannis Theorem. And ಇದು ನಿಮ್ಗೆ ಗೊತ್ತಿರಬೇಕು, ಇದು ಕೂಡ ವರ್ಟಿಕಲ್ ಹಿಂಗೆ ಈ ತರ ಮೂವ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಇದು ಟೋಟಲ್ ಆಂಗಲ್ ಏನಾದ್ರೂ 30 ಡಿಗ್ರಿ ಇದ್ರೆ ವಾಟ್ ಇಸ್ ದಿಸ್ ಆಂಗಲ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 15 ಡಿಗ್ರಿ. ಇವಾಗ ನೋಡಿ 1 2 3 ಫೋರ್ಸ್ ಇದೆ, 3 ಆಂಗಲ್ಸ್ ಬೇಕು ನಂಗೆ ಇವಾಗ. ನೋಡಿ ದಿಸ್ ಇಸ್ ದ ಫೋರ್ಸ್, ಈ ಫೋರ್ಸ್ಗೆ ಆಂಗಲ್ ನ ನೋಡಿ. ಸೊ ದೇರ್ಫೋರ್ ವೆಯ್ಟ್ ತಗೊಂಡಾಗ ಇದ್ರದ್ದು ಎರಡು ಅಪೋಸಿಟ್ ಆಂಗಲ್ 90 ಪ್ಲಸ್ ಥೀಟಾ, ದಟ್ಸ್ ಈಕ್ವಲ್ ಟು 90 ಪ್ಲಸ್ 15 is equal to 105. Look at the angle between them. Total angle is 180. 180 and 15 ಕಳೆದ್ರೆ ಎಷ್ಟಾಯ್ತು? 165. This angle is equal to 90. You know that each ball is in equilibrium due to the 3 forces acting on them. Then from Lannis theorem, you know that first year piece ನ ಚೆನ್ನಾಗಿ ಜ್ಞಾಪಕ ಇರಬೇಕು. So this is the weight W sine of 105. That should be equal to F sine of 165. That should be equal to the tension T by sine of 90. First year pieces apply ಮಾಡಿ. ನಿನಗೆ ಈಗ ಬೇಕಾಗಿರೋದು ಏನು ಅಂದ್ರೆ what you want to calculate is F. Equate these two. Therefore, in the place of W we can write mg sin 105 can be written as 90 plus 15. This F is not known. It can be written as sin of 90 plus 75 or 180 minus 15. Now what you have to do is M value you know. He has given the value of M. But the value of the mass is equal to 10 milligram and therefore it is 10 into 10 to the power of minus 3 into 9.8 whole divided by sine of 90 cos 15 it is. That's equal to F divided by this is equal to cos of 75 degree. So use your Clark's table and you work it out. So your F comes out to be equal to ಚೆನ್ನಾಗಿ ಜ್ಞಾಪಕ ಇರಬೇಕು. This is 9.8 into 10 is equal to 98 into 10 to the power of minus 3 cosine of 75 degree and this is cosine of 15 degree. You substitute and get the value and when you substitute that value in the equation number 1 you will get the final value. ಇದನ್ನು ನೀವು ವರ್ಕೌಟ್ ಮಾಡಬೇಕು. ನ್ಯಾಚುರಲ್ ಕೊಸೈನ್ ಹೆಂಗೆ ಕಂಡುಹಿಡಿಯೋದು? ಇದು 15 ಡಿಗ್ರಿ 75 ಡಿಗ್ರಿ ವರ್ಕೌಟ್ ಮಾಡಿ F ಬರುತ್ತೆ. F ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ D ಗೊತ್ತಿರುತ್ತೆ. So you get the value. ಇಲ್ಲಿ ನೀವು ಬೇಕಾದ್ರೆ ಇನ್ನೂ ಕ್ಲಿಯರ್ ಆಗಿ ಮಾಡ್ಕೋಬಹುದು. ಏನ್ ಗೊತ್ತಾ ಇನ್ನೂ ಕ್ಲಿಯರ್ ಅಂತಂದ್ರೆ ನೋಡಿ D value is known to you. The value D is equal to 0.1 ಇದೆಯಲ್ಲ 1/10 ಅಂತಾನೂ ಬರೀಬಹುದು. Therefore this you can write it as 9 into 10 to the power of 9 into Q square whole divided by 1/10 square and therefore your Q square is equal to ಚೆನ್ನಾಗಿ ಜ್ಞಾಪಕ ಇರಬೇಕು Q square is equal to so it is once again you can simplify this. The next step you can write the Q square. Here it is F is equal to 9 into 10 to the power of 11 into Q square. Therefore your Q is equal to square root of F divided by 9 into 10 to the power of 11. That you can take it as equation number 1. ಇವಾಗ ಇಲ್ಲಿ F ಬರುತ್ತಲ್ಲ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ. ಅರ್ಥ ಆಯ್ತಾ? Pit balls each of mass 5 into 10 to the power of minus 4 kg are suspended from the same point by a silk thread of equal length. Equal charges are given to these balls which separate out until the threads enclose an angle of 90 degree between them. If in this position distance between them is 0.3, calculate the magnitude of the charge. So problem number 12. I hope you have understood this one. There are two balls. These two balls are suspended from the silk thread. He has given the mass of each ball and he says the charge on this ball is Q, charge on the other ball is Q and the distance between these two balls is equal to 0.3 meter. And you know that they repel each other and ಎಲ್ಲಿವರೆಗೆ ರಿಪೆಲ್ ಆಗುತ್ತೆ ಅಂತಂದ್ರೆ till the angle between them become 90 degree. ಇವೆರಡರ ನಡುವೆ ಇರೋದು 90 ಡಿಗ್ರಿ ಆಗಲ್ವರೆಗೂ ಕೂಡ ಅದು ರಿಪೆಲ್ ಆಗುತ್ತೆ. ಚೆನ್ನಾಗಿ ಜ್ಞಾಪಕ ಇರೋದಕ್ಕೋಸ್ಕರ ಈ ಫಿಗರ್ನ ಸ್ವಲ್ಪ ಸಾಧ್ಯವಾದ ಮಟ್ಟಿಗೆ ಆ ಥರ ಬರ್ಕೊಳ್ಳಿ. till the angle between them is equal to 90 degree. ಟೋಟಲ್ ಆಂಗಲ್ 90 ಆದರೆ ರಿಮೆಂಬರ್ ಇವರ ಹಾಫ್ ಆಂಗಲ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎಷ್ಟಾಗುತ್ತೆ 45 ಡಿಗ್ರಿ ವಿಚ್ ವಿ ಕ್ಯಾನ್ ಕಾಲ್ ಇಟ್ ಆಸ್ ಥೀಟಾ ಅಂತ ಕರ್ಕೊಳ್ಳೋಣ. ಆಯ್ತಾ? ಈಗ ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ ಇದು ಇದನ್ನ ರಿಪೆಲ್ ಮಾಡುತ್ತೆ, ಇದು ಈ ಬಾಲ್ ರಿಪೆಲ್ ಮಾಡುತ್ತೆ. ಅದಕ್ಕೆ ಕರೆಕ್ಟ್ ಆಗಿ ಡೇಟಾ ಬರ್ಕೊಳ್ಳಿ. ಹಿ ಹ್ಯಾಸ್ ಗಿವನ್ ದ ಮಾಸ್ ಆಫ್ ದಿಸ್ ಬಾಲ್ ಆಸ್ 5 into 10 to the power of minus 4 kg. He says equal amount of charges are given and then and the separation between them is equal to 0.3, and he says find the magnitude of the charge. It's the same problem what we solved yesterday, that according to the inverse square law, Coulomb's law, Coulomb's inverse square law, so you are calculating the force between them as 1 by 4 pi epsilon naught into Q divided by d square. And you know that, so we can write it is to be equal to 9 into 10 to the power of 9 Q square by d square. And d you can substitute if you want, or you can substitute at the later stage, not a problem, because he has given it as a 0.3. You can make it as 3 into 10 to the power minus 1 meter, so that the calculation becomes very easy now, and therefore it becomes 3 into 10 to the power minus 1 whole square. You rearrange the terms and you know that your f into this value is equal to 9 into 10 to the power minus 2. This is 9 into 10 to the power of 9 into Q square. These two 9 get cancelled. And you know that your Q is equal to F divided by, or F into, look here, this is 10 to the power of minus 2. This, if it comes here, it will be 10 to the power of minus 9. And therefore, it is equal to 10 to the power of minus 11. Equation number 1. That's all. Now you want to calculate the force acting on each ball. And you know that from Lannis Theorem, by applying the Lannis Theorem, which you have studied in the first year PUC, this ball is in equilibrium due to the 3 forces. Same kind of problem should not be done, but sometimes you will expect us to do these things. This is a weight acting is equal to m into g, and this is the tension T. And you know that this is equal to theta, then it becomes 90 plus 45 becomes 135. And this is 180 minus 45, becomes this also 135. Now you apply the Lannis theorem, according to which what you want is the force divided by other two forces are these two, that is sine of 135. This should be equal to another force, that is W, and angle between the other two forces is equal to sine of 135. Look, in both the cases, the numerator is going to be the same, and therefore your F is equal to W, which is equal to mg. Now you substitute all these things in the equation number 1, therefore your Q is equal to m into g, so therefore mg into 10 to the power of minus 11, and he has given the value of m as 5 into 10 to the power of minus 4, g is equal to 9.8 into 10 to the power minus 11. You know that 9.8 into 5 is equal to 49 into 10 to the power of minus 15. Okay, it is 9.8 into 5 is equal to 49, 10 to the power of minus 4. And I think the value is given to be, the given data is 5 into 10 to the power of the mass is given to be 10 to the power minus 4. Yes. And therefore it is minus 15. Always make this as a even power, because it's very difficult for the odd calculations. So you better make it as a 490, okay? So therefore this comes out to be root of 49 into 10 into, or 4.9 you can make it as, it's equal to 4.9. You can make it as equal to 10 to the power of minus 16. Hegadru madi. Either you divide by that minus 16 arrow madi, minus 14 arrow madi, paravagilla. So therefore if you 10 anta madre, it becomes 10 to the power minus 16. Now your Q is equal to, finally, square root of 49 is 7, square root of 10 is equal to 3.162, and that's equal to minus 8. And therefore your values are 23, 7, 11, 22 into 10 to the power minus 8 Coulomb, or you can call it as, you can just return and you can bring it to nano Coulomb, 221 nano Coulomb, or just you can put it as equal to 22 into 10 to the power minus 8 Coulomb. That's all the answer. This is very easy compared to the yesterday's problem, this problem is little bit easier. Okay. Question number 18 ನಲ್ಲಿ ನೀವೇ ಮಾಡಬೇಕು, ಬಟ್ ಅದೊಂದು ಸ್ವಲ್ಪ ಒಳ್ಳೆ ಕ್ವಶನ್. ಎ ಚಾರ್ಜ್ ಆಫ್ 8.85 into the power nanocoulomb is inside the rectangular box of length 0.4 meter, breadth 3 meter, height 0.2. Calculate the flux of electric induction. Calculate the flux of electric field. ಅಂದ್ರೆ ನಿಮಗೆ ಜ್ಞಾಪಕ ಇರಬೇಕು, he has this kind of thing. He has put a charge inside. Now he says what the flux passing through this. So you want to calculate the flux through this one. What is the formula for the flux? The flux passing through the closed surface is given by the formula 1 by epsilon naught into the charge enclosed, and this 1 by epsilon naught into 1, you know the value of epsilon naught, 8.854 into 10 to the power of minus 12, and the value of the Q is equal to, he has given it as a 8.85 nanocoulomb. Nano means minus 9, it gets cancelled, and when it comes to the numerator, cancel it there only, and your flux is equal to, remember, 10 to the power of minus 12. If it comes to the numerator, it is plus 12, and it is 10 to the power of 3. Then what's the unit of electric flux? See, field is equal to flux by area. Flux is equal to field into area. So that is Newton per Coulomb for the field. For area, it is meter square. We can write this as a unit. Okay? I hope the unit of flux, it is 1 Newton per Coulomb for the field. For area, it is meter square. This is one part. 18 ನಲ್ಲಿ it's a sub question. Look at the another sub question in that. Another sub question that he has given is, okay, the flux of electric induction through the surface. Yes sir, the flux of electric induction is also called as a total normal electric induction is equal to total charge enclosed. This is the other statement of Gauss theorem. Remember, one statement of Gauss theorem ನಿಮ್ಗೆ ಏನು ಗೊತ್ತಿದೆ ಅಂತಂದ್ರೆ, your flux phi is equal to 1 by epsilon naught times the total charge enclosed. ಅಲ್ವಾ? Flux formula ಏನು? You have seen summation E cos theta into ds, that's equal to 1 by epsilon naught into q. ಇವಾಗ ಇದನ್ನ ಇಲ್ಲಿ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡಿದರೆ ಆವಾಗ ಐ ವಿಲ್ ಗೆಟ್ ದಿಸ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಆಸ್ epsilon naught into E cos theta into ds is equal to q. ಆವಾಗ ಈ ವ್ಯಾಲ್ಯೂ ಇದೆಯಲ್ಲ, ಇದನ್ನ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಎ ಟೋಟಲ್ ನಾರ್ಮಲ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಇಂಡಕ್ಷನ್. TNEI ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೆ, ನಿಮ್ಗೆ ಅದು ಜ್ಞಾಪಕ ಇರಬೇಕು, ಅಲ್ಲೇನು ಇನ್ಕಂಪ್ಲೀಟ್ ಏನಾಗಿಲ್ಲ. ಟೋಟಲ್ ನಾರ್ಮಲ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಇಂಡಕ್ಷನ್ ಈಸ್ ಗಿವನ್ ಬೈ ದ ಫಾರ್ಮುಲಾ ಟೋಟಲ್ ಚಾರ್ಜ್ E ಅಂತ ಹೇಳಿದ್ವಿ. ಟೋಟಲ್ ನಾರ್ಮಲ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಇಂಡಕ್ಷನ್ ಅಂದ್ರೆ ಏನು ಅಂತ ಕೇಳಿದಾಗ ನಿನ್ನೆ ನಾನು ಹೇಳಿದೆ, ಒನ್ ಆಫ್ ದ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ ದ ಫ್ಲಕ್ಸ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ಗಾಸ್ ಥಿಯರಮ್ ಇಸ್ ದಿಸ್. Another expression to calculate the flux is equal to, you know that it is summation of E cos theta into ds ಅಂತ. ಇವೆರಡನ್ನು ಈಕ್ವೇಟ್ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ, your epsilon naught comes here, and therefore that sigma epsilon naught into E cos theta into ds is called as a q, and that is what we call it as a total normal electric induction. Andre this whole thing we call it as a total normal electric induction. That is given by the value 8.85 into 10 to the power of, yesterday he had given the charge as so much of nanocoulomb, and that's all. So therefore, ಅದಕ್ಕೆ ನಿಮ್ಮ ಕೆಲಸನೇ what's the unit of total normal electric induction ಅಂದ್ರೆ ಕೂಲಂಬ್ ಗೊತ್ತಿರಬೇಕು. ಯಾಕಂದ್ರೆ what is total normal electric induction is equal to the charge enclosed. What is the unit of charge? Coulomb. The force due to multiple charges. The force due to multiple charges. ಇದೇ ನೀವೇನು ತುಂಬ ಏನು ತಲೆ ಕೆಡಿಸ್ಕೊಳ್ಳೋಷ್ಟು ಏನಿಲ್ಲ ಇದು, ಅದಕ್ಕೆ ನಾನು ಅವಾಗೇನು ಮಾಡಲಿಲ್ಲ. ಯಾಕೆಂದರೆ ಇವೆಲ್ಲ ಏನು ಅಂತಾದ ಇಂಪಾರ್ಟೆಂಟ್ ಏನಲ್ಲ. ಫೋರ್ಸ್ ಡ್ಯೂ ಟು ಮಲ್ಟಿಪಲ್ ಚಾರ್ಜಸ್ ಅಂತ. ಈಗ ನೀವು ಕುಲುಮ್ಸ್ ಇನ್ವರ್ಸ್ ಸ್ಕ್ವೇರ್ ಲಾ ನೀವು ನೋಡಿದ್ದೀರಾ. ಕುಲುಮ್ಸ್ ಇನ್ವರ್ಸ್ ಸ್ಕ್ವೇರ್ ಲಾ ಅದನ್ನು ನಾನು ನಿಮ್ಗೇನು ಹೇಳಿದ್ವಪ್ಪ, ಇಲ್ಲಿ ಹಿಯರ್ ಇಸ್ ಎ ಚಾರ್ಜ್ Q1 ಅಂತ ಇರುತ್ತೆ. Q1 ಇಸ್ ಎ ಚಾರ್ಜ್. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿ ಇಲ್ಲೊಂದು ಚಾರ್ಜ್ ಇರುತ್ತೆ, ದಟ್ಸ್ ಈಕ್ವಲ್ ಟು Q2 ಅಂಡ್ ಯುವರ್ Q2 ಇಸ್ ಅಟ್ ಎ ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ R12. ಇದು ಎರಡು ಚಾರ್ಜ್ ಇದ್ದಾಗ ನಾವು ಕಂಡು ಹಿಡಿದಿದ್ವಿ. ಅವಾಗ ವಿ ರೋಟ್ ಎ ಕುಲುಮ್ಸ್ ಇನ್ವರ್ಸ್ ಸ್ಕ್ವೇರ್ ಲಾ ಏನಂತ ಬರೆದ್ವಿ, ಕುಲುಮ್ಸ್ ಇನ್ವರ್ಸ್ ಸ್ಕ್ವೇರ್ ಲಾ ವಿ ರೋಟ್ ಇಟ್ ಆಸ್ 1/4πε0 into Q1 Q2 divided by distance between them R12 plus into that unit vector R12 ಅಂತ ಬರ್ತದೆ. ಇದು ಯಾವಾಗ ಒಂದು ಚಾರ್ಜ್ ಇದ್ದಾಗ we shall call it as F12 ಅಂತ ಬರೆಯೋಣ, ಫೋರ್ಸ್ ಬಿಟ್ವೀನ್ 1 and 2. ಈಗ ನಿಮ್ಮ ಹತ್ರ ಸಪೋಸ್ ಇವಾಗ ಇನ್ನೊಂದು ಚಾರ್ಜ್ ಇದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ಇನ್ನೊಂದು ಚಾರ್ಜ್ ಇಲ್ಲೆಲ್ಲೋ ಇದೆ, ಹಿಯರ್ ಇಸ್ ಅನದರ್ ಚಾರ್ಜ್, ದಟ್ ಇಸ್ ಲೆಟ್ ಅಸ್ ಸೇ Q3. ಅವಾಗ ಅವೆರಡರ ನಡುವೆ ಇರೋ ಡಿಸ್ಟೆನ್ಸ್ ನ we shall call it as 13. Sir, what is the force between them? Then force between them is given by the formula. It is F13 is equal to 1/4πε0 Q1 Q3 divided by R13 square with R13 unit vector. ಒಂದೊಂದೇ ಫೋರ್ಸ್ ಇದೆ ಹೀಗಿರುತ್ತೆ. ಇವಾಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಿನ್ನ ಹತ್ರ ಇಲ್ಲೊಂದು ಫೋರ್ಸ್ ಇದೆ, ಇಲ್ಲೊಂದು ಚಾರ್ಜ್ ಇದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ, ಲೆಟ್ ಅಸ್ ಸೇ Q4 and it is at a distance of R14 ಅಂತ ಇಟ್ಕೊಂಡಿರೋಣ. ಇದೇ ತರನೇ ನಾವು ಬರೀತಾ ಹೋಗ್ತೀವಿ. ಸರ್ ಅವಾಗ ಇವೆಲ್ಲ ಚಾರ್ಜಸ್ ಇರುತ್ತಲ್ಲ, ಈ ಎಲ್ಲ ಚಾರ್ಜಸ್ ಇಂದ ನಮಗೆ ವಾಟ್ ಇಸ್ ದ ನೆಟ್ ಫೋರ್ಸ್ ಆಕ್ಟಿಂಗ್ ಆನ್, ವಾಟ್ಸ್ ದ ಟೋಟಲ್ ಫೋರ್ಸ್. ಆವಾಗ ದಟ್ ಟೋಟಲ್ ಫೋರ್ಸ್ ಕ್ಯಾನ್ ಬಿ ಗಿವನ್ ಬೈ ದ ಫಾರ್ಮುಲಾ F12 F13 F14 ಎಕ್ಸೆಟ್ರಾ ಹೀಗೆ ಬರೀಬಹುದು. ಅದು ಬರೆದಾಗ ನಿಮ್ಗೆ ಏನ್ ಗೊತ್ತಾಗತ್ತೆ, 1/4πε0 Q1 Q2 divided by R12 square with R12 n cap. ಸೊ ಈ ತರ ಬರ್ತಾ ಹೋಗುತ್ತೆ. ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಬಿಟ್ರೆ ಎಲ್ಲದನ್ನು ಅದೇ ತರ F13 ಮಾಡಿ ಎಲ್ಲ ಮಾಡಿದ್ರೆ ಅವಾಗ ನೀವು ನೋಡ್ತೀರಿ ಇಲ್ಲಿ ಎಲ್ಲಾ ಕಡೆಗೂ ಕೂಡ ಇವನ್ ಇಫ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಫಾರ್ ದ ಸೆಕೆಂಡ್ ಒನ್ 1/4πε0 into Q1 Q3 divided by R13 square with R13, so that's a unit vector. ಇಲ್ಲಿ ಎಲ್ಲಾ ಕಡೆ ಏನ್ ಕಾಮನ್ ಫ್ಯಾಕ್ಟರ್ ಬರುತ್ತೆ ಅಂತಂದ್ರೆ ಇಂಥದ್ದು ಟೂ ಮೆನಿ ಚಾರ್ಜಸ್ ಇದ್ದಾಗ Q4 Q5 Q6 ಈ ತರ ಸುಮಾರು ಚಾರ್ಜಸ್ ಇದ್ದಾಗ ಆವಾಗ ನಿಮ್ಗೆ ಇಲ್ಲಿ ಹೊರಗಡೆಗೆ ಕಾಮನ್ ಫ್ಯಾಕ್ಟರ್ ಬರೋದು ಇಟ್ ಈಸ್ Q1/4πε0. ಅದು ಎಷ್ಟು ಬೇಕಾದ್ರೂ ಇರಲಿ. ಅವಾಗ ನೀವೇನ್ ಮಾಡ್ಬೇಕು, ಇದಿಷ್ಟನ್ನ ತಗೊಂಡಾಗ ಈ ಶುಡ್ ಟೇಕ್ ಎ ಸಮೇಷನ್. ಅವಾಗ ಇದನ್ನ ಏನಂತ ಬರೀರಿ, QI ಅಂತ ಬರೀರಿ ಇನ್ ಜನರಲ್, ಇದು ಕಾಮನ್, ಇದು ಡಿವೈಡೆಡ್ ಬೈ ಇಲ್ಲಿ ಏನ್ ಬರುತ್ತೆ R1i ಸ್ಕ್ವೇರ್ ಅಂತ ಬರೀರಿ. R ಸ್ಕ್ವೇರ್ 1i, ಚೆನ್ನಾಗಿ ಜ್ಞಾಪಕ ಇರಬೇಕು, R ಸ್ಕ್ವೇರ್ 1i with this unit vector. So this unit vector is R1i, that's all. ಇವಾಗ ನೋಡಿ ಇದು ಬೇಕಲ್ವಾ, ಪುಟ್ I is equal to 2. ನೀವು ಇದನ್ನ I is equal to 2 ದಿಂದ ನೀವೆಷ್ಟು ಬೇಕಾದ್ರೂ ಕೂಡ ನೀವು ಬರೀಬಹುದು. ಸೊ ಇಫ್ ಯು ವಾಂಟ್ ದ 2, ಸೊ R12 square and Q12 R12, so you will get it like this. In general ಇದು ಬರೀಬಹುದು. ಇದನ್ನ ಎಲ್ಲಾರ ಅಪ್ಪಿ ತಪ್ಪಿ ನಿಮ್ಗೆಲ್ಲಾರು ಕೇಳಿದರೆ 1 ಮಾರ್ಕಿಗೆ ಇಲ್ಲಿ 2 ಮಾರ್ಕ್ಸಿಗೆ ಕೇಳಿದ್ರೆ ಇದನ್ನ ನೀವು ಬರೀಬೇಕು ಅಷ್ಟೇ. ಅದಕ್ಕೆ ನಾನು ಮೊದಲಿಂದ ನಿಮ್ಗೆ ತಗೊಳ್ಳಿಲ್ಲ ಇದನ್ನ. ಬಟ್ ಏನಂದ್ರೆ ಎವ್ರಿ ಟೈಮ್ ಯು ಹ್ಯಾವ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಅಂಡ್ ದ ಡೈರೆಕ್ಷನ್. ಅರ್ಥ ಆಯ್ತಾ? ಇದು ಗೊತ್ತಿರಬೇಕು. ಇದು ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೋರ್ಸ್ ಡ್ಯೂ ಟು ಮಲ್ಟಿಪಲ್ ಚಾರ್ಜಸ್ ಅಂಡ್ ದಿಸ್ ಈಸ್ ಇನ್ ಅಕಾರ್ಡೆನ್ಸ್ ವಿತ್ ದ Coulomb's law. ಇದು ಚೆನ್ನಾಗಿ ಗೊತ್ತಿರಬೇಕು. ಇಟ್ ಈಸ್ ಇನ್ ಅಕಾರ್ಡೆನ್ಸ್ ವಿತ್ ದ Coulomb's inverse square law. So we can write it like this. ಆಯ್ತಾ? ಇದು ಇವೆರಡಕ್ಕೆ if you want to calculate it for the whole charges you add this one. Okay, ಇದೇ ತರನೇ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಬರುತ್ತೆ. ಸೊ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಡ್ಯೂ ಟು ಸಿಸ್ಟಮ್ ಆಫ್ ಚಾರ್ಜಸ್, ಇದೇ ತರನೇ ಡ್ಯೂ ಟು ಸಿಸ್ಟಮ್ ಆಫ್ ಚಾರ್ಜಸ್ ಅಂತ. ಏನಪ್ಪಾ ಇದು, ಇದೇ ತರನೇ ಮಲ್ಟಿಪಲ್ ಚಾರ್ಜಸ್ ಇರುತ್ತಲ್ಲ, ಅದೇ ತರನೇ ಸಿಸ್ಟಮ್ ಆಫ್ ಚಾರ್ಜಸ್ ಇದ್ದಾಗ ನೀವು ಹೇಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀರಾ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅನ್ನ. ಅವಾಗ ಫೈನಲ್ ಫಾರ್ಮುಲಾ ಜ್ಞಾಪಕ ಇಟ್ಕೊಂಡಿರಿ. ಇವೆಲ್ಲ ಜಸ್ಟ್ ಫೈನಲ್ ಫಾರ್ಮುಲಾ ಗೊತ್ತಿದ್ರೆ ಸಾಕು. ಐ ಹೋಪ್ ನಿಮಗೆ ಜ್ಞಾಪಕ ಇರಬೇಕು. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನನ್ನ ಹತ್ರ ಇಲ್ಲೊಂದು ಐಸೋಲೇಟೆಡ್ ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ ಇತ್ತು ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಪಾಯಿಂಟ್ P at which we call it as an electric field due to this one is equal to E1. ಅಂಡ್ ಇಲ್ಲಿಂದ ಇಲ್ಲಿವರೆಗಿರೋ ಡಿಸ್ಟೆನ್ಸ್ ಯು ಕ್ಯಾನ್ ಕಾಲ್ ಇಟ್ ಈಸ್ ಈಕ್ವಲ್ ಟು R1P ಅಂತ ಕರ್ಕೊಳ್ಳಿ. ಬಿಕಾಸ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ R1, ದಟ್ಸ್ ದ ಡಿಸ್ಟೆನ್ಸ್ ಆಫ್ Q1 ಫ್ರಮ್ ದ ಪಾಯಿಂಟ್ P. And you know that when you want to calculate the electric field at that point, you must put a test charge. ತುಂಬಾ ಚೆನ್ನಾಗಿ ಜ್ಞಾಪಕ ಇರಬೇಕು. ಅರ್ಥ ಆಯ್ತಾ? ಅವ ನೀವೇನ್ ಮಾಡ್ತೀರಾ? Because of this, the electric field at that point is given by the formula 1 by 4 pi epsilon naught into Q1 by D square. D ಅಂದ್ರೆ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ? R1P square with R1P as a unit vector. ಇವಾಗ ಏನಾಗುತ್ತೆ? ನೀನು ಇಲ್ಲೊಂದು ಚಾರ್ಜ್, ಇಲ್ಲೆಲ್ಲೋ ಒಂದು ಕಡೆ ಚಾರ್ಜ್ ಇದೆ. ಯು ಹ್ಯಾವ್ ಅನದರ್ ಚಾರ್ಜ್ Q2. ಇಲ್ಲೆಲ್ಲೋ ಇದೆ Q2. ಸರ್, ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ವಾಟ್ ಇಸ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್? ದಟ್ಸ್ R. You can call it as a 2P. So therefore, you know that ಅಕಸ್ಮಾತ್ ಆ ಇನ್ನೊಂದು ಚಾರ್ಜ್ ಇದ್ರೆ ಅದರದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇಸ್ ಗಿವನ್ ಬೈ 1 by 4 pi epsilon naught into Q2 divided by R 2P square with the unit vector 2P. ಅರ್ಥ ಆಯ್ತಾ? ಇದು ಈ ತರ ಬರೀಬೇಕು. ಇವಾಗ ನೀನು ಸರ್ ಟೂ ಮೆನಿ ಚಾರ್ಜಸ್ ಇದೆ ಸರ್, I have one more charge here that's equal to Q3 and I want to calculate the electric field here, and I have one more charge Q4, so ನನಗೆ ಎಲ್ಲಾ ಕಡೆನೂ electric field ಕಂಡುಹಿಡಿಯಬೇಕು. ಅವಾಗ you can calculate the magnitude of the electric field. ಇದೇ ತರನೇ ನೀವು ಆಡ್ ಮಾಡ್ಕೊಂಡು ಹೋಗಿದ್ದಾಗ your E is equal to E1 plus E2 plus E3 etc. ಎಲ್ಲ ಆಡ್ ಮಾಡಿದ್ದಾಗ ನಿಮ್ಗೆ ಏನ್ ಬರುತ್ತೆ? ಫೈನಲಿ 1 by 4 pi epsilon naught is a common factor and with summation of, ಇಲ್ಲಿ ನೋಡಿ ಎವ್ರಿ ಟೈಮ್ ಇದು ಚೇಂಜ್ ಆಗ್ತಾ ಇರ್ತದೆ. ದಟ್ ಯು ಕ್ಯಾನ್ ರೀಡ್ ಆಸ್ ಎ QI ಡಿವೈಡೆಡ್ ಬೈ R. ನೋಡಿ ಇಲ್ಲಿ 1P, ಇಲ್ಲಿ 2P, ಇಲ್ಲಿ 3P ಅದೇ ತರ ಬರ್ತಾ ಹೋಗುತ್ತೆ ಅಲ್ವಾ? ಆವಾಗ ಅದನ್ನ ಏನ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಯು ಶುಡ್ ರೈಟ್ ಇಟ್ ಆಸ್ IP. ಇದಕ್ಕೊಂದು ಸ್ಕ್ವೇರ್ ಹಾಕಬೇಕು, R ಗೊಂದು ಸ್ಕ್ವೇರ್ ಹಾಕಬೇಕು ವಿತ್ ಯೂನಿಟ್ ವೆಕ್ಟರ್. ಯೂನಿಟ್ ವೆಕ್ಟರ್ ಏನಂತ ಬರೀತೀರಾ? ಇಟ್ ಈಸ್ IP. ಇಷ್ಟು ಚೆನ್ನಾಗಿ ಜ್ಞಾಪಕ ಆಗಬೇಕು ಅಷ್ಟೇ. ಆಮೇಲೆ ನಿಮ್ಗೆ ಗೊತ್ತಿದೆ ಡೈರೆಕ್ಷನ್ ಕಂಡು ಹಿಡಿಬೇಕಾದ್ರೆ ನೀವು ಬಹಳ ಸ್ವಲ್ಪ ಸರ್ಕಸ್ಗಳೆಲ್ಲ ಮಾಡಬೇಕು. ಇದು ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್. ಆ ಡೈರೆಕ್ಷನ್ ಕಂಡು ಹಿಡಿಬೇಕಾದ್ರೆ ನಾನು ನಿಮ್ಗೆ ಯಾವಾಗಲೂ ಹೇಳಿದ್ದೆ, ಆ ಪ್ಯಾಂಟ್ ಅಂತ ಇದ್ರೆ ಅಪ್ಲೈ ಮಾಡಿ. ಸೊ ಇವಾಗ ನೋಡಿ ಡೈರೆಕ್ಷನ್ ಕಂಡು ಹಿಡಿಬೇಕಾದ್ರೆ ಇಂಥ ಕಡೆಗೆಲ್ಲ ಎಷ್ಟು ಕಷ್ಟ ಇದೆ ಗೊತ್ತಾ? ಇಲ್ಲಿ ನೋಡಿ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇದ್ರದ್ದು ಫೀಲ್ಡ್ ಇಸ್ ಡೈರೆಕ್ಟೆಡ್ ಲೈಕ್ ದಿಸ್. ಸೊ ಇದರಿಂದ ಫೀಲ್ಡ್ E1 is directed in this fashion. ನೋಡಿ ಇದರಿಂದ ಬರೋ ಫೀಲ್ಡ್ ಡೈರೆಕ್ಷನ್ ಹಿಂಗಿದ್ರೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ 45 ಡಿಗ್ರಿ ಇದ್ರೆ, ಸೊ ಇದು ಇಟ್ ಈಸ್ ಡೈರೆಕ್ಟೆಡ್ ಲೈಕ್ ದಿಸ್ E2. ಆಮೇಲೆ ನೋಡಿ ಇದೇನಾದ್ರೂ Q3 ಇದ್ರೆ ಇದ್ರದ್ದು ಫೀಲ್ಡ್ ಇನ್ ಡೈರೆಕ್ಷನ್ ಇಟ್ ಈಸ್ ಡೈರೆಕ್ಟೆಡ್ ಲೈಕ್ ದಿಸ್ E3. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಈ 3 ಇದ್ರೆ ನಿಮ್ಗೆ ಈ 3ಕ್ಕೂ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಕಂಡು ಹಿಡಿಬೇಕು. ಅಂದ್ರೆ magnitude you can calculate it easily. Calculation of the electric field is a cumbersome procedure, or we call it as a difficult procedure. ಇಷ್ಟು ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್ಸ್ ಗೊತ್ತಿರಲಿ ಸರ್. ಇಷ್ಟೆಲ್ಲ ಹುಡುಗರೆಲ್ಲ ಕೇಳ್ತಾರ. ದೀಸ್ ಆರ್ ಆಲ್ ನಾಟ್ ದ ಕ್ವಶನ್ಸ್ ಟು ಬಿ ಆಸ್ಕ್ಡ್. ಇವೆಲ್ಲ ಏನಂದ್ರೆ 1 ಮಾರ್ಕಿಗೆ ಈ ತರ ಇನ್ ಜನರಲ್ ಮಲ್ಟಿಪಲ್ ಚಾರ್ಜಸ್ ಕೇಳಿ 2 ಮಾರ್ಕ್ಸ್. ಅಕಸ್ಮಾತ್ 1 ಮಾರ್ಕ್ ಕಡಿಮೆ ಆಗುತ್ತೆ ಅಂತ ಅನ್ಸಿದ್ರೆ ಇದಕ್ಕೆ 2 ಮಾರ್ಕ್. ರೈಟಿಂಗ್ ದ ಫಾರ್ಮುಲಾ 1 ಮಾರ್ಕ್. ಆಮೇಲೆ ಇಲ್ಲಿ ಏನೇನು ಟರ್ಮ್ ಇದೆ ಅಂತ ಹೇಳಿದ್ದಕ್ಕೆ ಇನ್ನೊಂದು 2 ಮಾರ್ಕ್ಸ್. ನೀವು ರೈಟ್ ಅಂಡ್ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೋರ್ಸ್ ಡ್ಯೂ ಟು ಮಲ್ಟಿಪಲ್ ಚಾರ್ಜಸ್ ಅಂದ್ರೆ ಬರೀ ಫಾರ್ಮುಲಾ ಬರೆದ್ಬಿಟ್ರೆ ನಿಮಗೆ ಮಾರ್ಕ್ಸ್ ಕೊಡಲ್ಲ. ನಿಮಗೆ ಕೊಡೋದು 1 ಮಾರ್ಕ್ ಕೊಡೋದು 2 ಮಾರ್ಕ್ಸ್ ಅಲ್ಲಿ. ಏನ್ ಸರ್ ನಾ ಫಾರ್ಮುಲಾ ಬರೆದಿದ್ದೀನಿ, ಈ ಟರ್ಮ್ ಹೇಳ್ಬೇಕಪ್ಪ, Q1 ಅಂದ್ರೆ ಏನು, QI ಅಂದ್ರೆ ಏನು, ಇವೆಲ್ಲ ಹೇಳ್ಬೇಕು ಅದೇನೇನು ಅಂತ. ಅವಾಗ ಫುಲ್ ಮಾರ್ಕ್ಸ್. ಸೊ ಇದು ಅಷ್ಟೇನೆ 2 ಮಾರ್ಕ್ಸ್ ಕೇಳಿದ್ದಾಗ ಈ ತರ ಬರೀಬೇಕು. ಫಿಗರ್ ಲೈನ್ ಬರೆಯೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಕೊಡೋ 2 ಮಾರ್ಕ್ಸ್ಗೆ ಅಷ್ಟೊಂದು ಮನ ಎಲ್ಲ ಬರೆಯೋಕ್ಕಾಗಲ್ಲ. ಅರ್ಥ ಆಯ್ತಾ? ಇದು ಗೊತ್ತಿರಲಿ.